Hello everyone. Now we all know that what is the meaning of motion. So now we are going to start our new topic, distance and displacement. Now assume that our particle is at A position at time t1 and it moves along the path A to C and C to D and reaches at point B at time t2. Then the total length of path ACB is our distance, and if we connect the line between A and C, means if we connect the straight line between our initial and final point, then we get displacement. So distance is scalar quantity because it has no specific direction. The direction varies with the time, but displacement has a magnitude as well as specific direction. So the displacement is vector quantity. Dimension of distance and displacement is only length, and the SI unit of distance and displacement is meter. From our last lecture we can say that relation between distance and displacement is distance is always greater than or equal to displacement. Now we are going to take one example. Here example is, if one person move on a semi-circle track during its morning walk, if he started at one end and reached at another end, and find the distance and displacement. Here radius of semicircle is 40 meter. Now path is semicircle and the radius of semicircle is 40 meter. So the distance is, according to our definition, distance is total length of path. Here total path or total track is a semicircle. So the distance is half of circumference. We all know that circumference is 2 pi r and half of circumference is 2 pi r by 2. 2 will cut. So the value of distance is only pi r. Here radius is 40 meter. So the value of r is 40 meter. So the answer is 40 pi. Now displacement. Displacement, according to definition of displacement, displacement is straight line or the shortest distance between initial and final point. Here initial point is suppose A and the final point is B. Then the distance between AB is a diameter. So the displacement is equal to diameter. The value of diameter is twice of radius. Here radius is 40 meter, so the displacement is 80 meter. Here our example is complete. Now our next topic is average speed and the instantaneous speed. Now take one example. If our particle is at point A at time t1, it travels towards B and reaches at B at time t2. Distance between A and B is suppose s. Then the average speed is defined as the total distance traveled by an object in a given time interval. Here time interval is delta t because time interval is t2 minus t1. So the average speed V average is equal to distance upon time interval, means s upon delta t. The average speed gives all over rapidity with which the particles move in a given interval of time. Now let's take one example. In a cricket match, a run rate is give the value of all over run divided by the total number of over. In that case, some overs are expensive and some are economical. Similarly, the value of average speed is vary with the time, because at a particular time the value of speed is maybe equal or maybe not equal to average speed. So if we want to find the particular value of speed at a particular point, then we have to find instantaneous speed. Now let delta s is a distance traveled in a particular time period. and time period is delta t. So the first initial time is t and the final time is t plus delta t. So the average speed is delta s upon delta t. Now if delta t approaches to 0, then delta s also approaches to 0. But ratio of delta s by delta t has some finite limit. So the value of instantaneous speed is limit delta t tends to 0, delta s by delta t. If we put the limit, then the value of delta s by delta t is ds by dt. So the value of instantaneous speed is ds by dt. So the average speed is defined for interval of time. And instantaneous speed is defined at a particular instant. Okay, if we want to find the average speed, then we can apply formula s upon delta t. But if we want to find the particular speed at a particular point, then we have to find instantaneous speed, because the average speed is only for a interval of time and the instantaneous speed is a particular instant. Okay, now if we plot the graph between distance versus time, then if our initial position is A at time t, after the interval of time our particle reaches at point B after the time t plus delta t, then the speed is slope of the tangent to the curve, means the speed of particle at point A is equal to the tangent. But for average speed is equal to the slope of the chord AB. But if we approach this time delta t to the 0, then our chord AB becomes tangent and it's give a instantaneous speed. So our average speed is delta s by delta t. But if we approach this time delta t tends to 0, then our slope become tangent to that point and gives the instantaneous speed. And instantaneous speed is ds by dt. So the small distance traveled at that point is v dt. Now if we want to know the total distance during the travel, then we have to sum in all the smallest distance, then we get total distance of traveling. Now if we plot the graph velocity versus time, suppose our position of particle at time t1 is at A and at time t2 the position of particle is at B, and our curve is like this. Then if we want to find the distance, then we can find the distance by calculating the area under the curve. Now the distance smallest distance ds is equal to v dt. Now we want to find the total distance, then we can take integration on both sides. Integration differentiation will be cancelled. So the distance is, here time limit is, initial time is t1 and the final time is t2. So the distance s is equal to integration t1 to t2 V dt. Okay, now the dimension and the SI unit. Dimension of speed and the SI unit of the speed. SI unit of the speed is, the formula of speed is distance upon time. Unit of distance is meter and the unit of time is second. So the SI unit is meter per second. Now the dimension. Dimension is M, L and T. Here M is present, so the length is present. The value of power of M is 1, so L1. Here time is present. Power of time is 1, but in a division, so the t is -1. So the dimension of speed is m0 L1 t minus 1.